Good morning, students. So today we will study the topic catalyst from the chapter surface chemistry. We know catalyst is a substance that alters the rate of a reaction by decreasing the activation energy. Now we will take one example. This is the production of ammonia from nitrogen gas and hydrogen gas. In this equation, in this reaction, the catalyst is used as a iron and promoter is used as a molybdenum. So it forms two molecules of ammonia gas. Right. So this is an example of an heterogeneous catalyst in which the reactant are in the gaseous phase, whereas the catalyst is in a solid phase. This reaction is important because this is the industrial process for the preparation of ammonia by the Born-Haber process. Here we must know that iron is a catalyst and molybdenum is a promoter. Now what is promoter? Now promoter is a substance that enhance or increase the activity of the catalyst. Okay, so this molybdenum increases the activity of the catalyst. So this is molybdenum is a promoter. In this reaction, then another important factor is poison. Now what are poisons? Poisons are the substances that inhibited the reaction, that does not allow the reaction to happen. Okay, that inhibit the reaction. For this reaction, carbon monoxide, okay, remember the carbon monoxide act as a poison for this reaction, whereas molybdenum act as a promoter. Now we'll look into the homogeneous catalyst. So homogeneous catalyst is a catalyst reaction is a reaction in which the reactant, the state of the reactant is same as the state of the catalyst is same as the state of the reactant. Okay, so here you can see one example. Sulfur dioxide, two molecules of sulfur dioxide plus, which is in gas state, reacts with one molecule of oxygen gas in the presence of one molecules of oxides of nitrogen to give two molecules of sulfur trioxide gas. Remember, we are not interested in the product. Okay, product may be in any of the state, but it has to be homogeneous with the reactant. Remember, the catalyst, the state of the catalyst, here it is a gas, it has to be the same. Okay, so both the reactants are in gaseous phase and the catalyst is also gaseous. Okay, you should not look at the product. Similarly, in a heterogeneous catalyst, where the phase means state of the catalyst is different, here it is a solid, right, whereas the phase or the state of the reactant is gaseous. So this type of reaction is known as heterogeneous catalysis reaction. We have already used one of this one. This is also heterogeneous catalysis reaction. Okay, you can choose any of the examples according to your convenience. Now coming to the absorption theory of heterogeneous catalysts, it says that first the reactants, okay, I'll put it A and B, it will get diffused towards the catalyst. Diffuse means the movement. Okay, so the first step is diffusion of reactants towards the surface of the catalyst. Then in the next step, this reactants gets adsorbed at the surface of the catalyst. It gets adsorbed at the surface of the catalyst. Then the chemical reaction takes place between the reactants. Okay, so A and B. Now reaction is taking place. Then after the reaction, what we see is the formation of the product. So formation C and D. Now product has been formed. Now since product has no affinity towards the catalyst, so it go away from the catalyst. So the diffusion of the product away from the catalyst. Okay, so it will go away from the catalyst. So these are the steps of heterogeneous catalysis reaction. A nice diagram is also given in your textbook. You can refer it. Say this is a catalyst, a surface of the catalyst having free valencies. We have already discussed this thing, that the molecules present at the surface, they are in the state of unrest, they have some surface energy, right? So they have since free valencies. So now this reactant A and B comes together and attach to this free valencies. Okay, any of these free valencies. So here we can see. So this is the adsorption of reactants by the catalyst at the surface. Then the reaction is taking place between the between the reactants. Okay, then the product has been formed. So this AB is the product here. Initially it's A plus B. Now AB is the product. Okay, so now product has no affinity towards the catalyst, so it goes away from the catalyst. There are two important features of solid catalysts. Number one is activity, number two is selectivity. Now activity of a catalyst, that depends upon the strength of chemisorption to a large extent. That means it has to. Okay, so if this is a catalyst, right, and A, B and B are the reactant. Now the first step, we know that A and B gets adsorbed at the surface of the catalyst. Now this adsorption should not be it has to adsorb, okay, and the next point is it should not be so strongly adsorbed that it could not, the reaction between A and B could not take place. Okay, so that should not be there. So it has to have a certain limited amount of force, that is basically we talk about van der Waals force between the catalyst and the adsorption, that must be of reasonable strength, right? So that is basically activity. Now selectivity is that we have noticed that we, okay, in general we say catalyst, okay, it does not participate in the formation of the product, it just participates in the reaction. Okay, but sometimes we have noticed that with the change in the catalyst, the product is also changed. For example, here carbon monoxide plus hydrogen, in the presence of nickel it forms methane plus water. Okay, here same reactant, carbon monoxide, okay, and again hydrogen, but we change the catalyst. Okay, with the change in the catalyst, what we have seen is the different product. Here methanol has been formed. Again the same reactant, carbon monoxide and hydrogen gas, the catalyst is copper, the product is your formaldehyde, right? So with the same reactant, with the change in the catalyst, we obtain the different product. Okay, so this is known as selectivity. So selectivity directs the type of product. The next topic is zeolites. What are zeolites? Zeolites are basically the good shape size selective catalyst. Okay, so these are shape selective catalyst. because of their honeycomb-like structure. They are microporous aluminum silicates with three-dimensional network of silicates in which some silicon atoms are replaced by aluminum atoms, giving aluminum oxygen silicon framework. The example of zeolite is ZSM5. It is used for the production of gasoline from alcohols. Next topic we discuss here is enzyme catalyst. What are enzyme catalysts? These are basically biochemical catalysts. Okay, so they are complex nitrogenous organic compounds which are produced by living plants and animals. They are actually the protein molecules of high molecular mass and form colloidal solution in water. The example of enzyme catalysts are invertase, gymase, maltase, urease. These are the example. They are very important, and particular example of enzyme is used for particular reaction only. It has been noticed that particular enzyme is used for particular reaction only. For example, invertase is used for the inversion of cane sugar, that is, cane sugar is reduced to glucose and fructose in the presence of invertase. Similarly, gymase, it converts glucose to ethyl alcohol and carbon dioxide. Similarly, there are other examples you can refer it. Maltase, it converts maltose to glucose. Urease, that converts urea to ammonia and carbon dioxide. Similarly, the enzyme lactobacilli converts milk into curd. There are important characteristics of enzyme catalyst, like they are most highly efficient. One molecule of enzyme may transfer 1 millionth molecule of the reactants per minute. Highly specific in nature, highly active under optimum temperature. You must know that temperature is 298 Kelvin to 310 Kelvin, as human body temperature is 37 degree Celsius. In terms of Kelvin, it is 310 Kelvin, and it suits for enzyme catalyst reaction. And it's highly active under optimum pH, that is pH from 5 to 7. Increased activity in the presence of activator and coenzymes. Like earlier we have learned about catalysts, they have a promoter and poison. Similarly, here the enzyme catalysts have activator and coenzyme. What are activators? Activators are generally metal ions such as sodium, magnesium ion, copper, cobalt. These when bonded to the enzyme molecules increase the catalytic activity. So this increases the activity of the catalyst. Now what are coenzymes? Coenzymes are the another enzymes that increases the performance or activity of the catalyst. Here also it has inhibitor and poisons, that inhibits the function of the catalyst. So here we'll discuss the mechanism of enzyme catalysis. Here normally it has been said that enzyme, they have cavity. So cavity has some active These are active sites and they have some functional group present in the cavities. They binds the substrate. Now this is our substrate. Now it follows the lock and key theory. Remember, particular lock is used for particular key. Therefore, only the particular key is fit in a particular lock, right? So similarly, particular enzyme is only useful for particular substrate. So it has its complementary shapes. See, look at this, the shape. I've just drawn this one. The shape of this substrate is complementary with the cavity of the enzyme. All right. So this is your substrate plus enzyme. Now substrate goes and attached with the enzyme. Now you can see here substrate, it fits into the enzyme's cavity, right? So now this is called substrate enzyme complex. Now the reactions between or the decomposition or whatever, the substrate has been converted into the product. Now see, now the product had different shape as that of substrate. So now the substrate has break into the two product. Here I've just done it. Okay, now this is called product enzyme complex. Now the product has no affinity towards the enzyme, so the product will come out from the enzyme cavity. Now you can look here, I have drawn this one. Now the product has been formed. The enzyme is now again free to take another substrate. Now the another substrate will come here and bind with the enzymes, and it forms again substrate enzyme complex. Then again the substrate will be broken into the product. Then products will come out from the enzyme. Again enzymes becomes free. So that means one enzymes can be used again and again. That is why the efficiency of enzyme is very high. Thank you.